This is the pattern for factoring a difference of cubes. So if you have a cubed minus b cubed, so a perfect cube minus a perfect cube, it's equal to a minus b times a squared plus ab plus b squared. You can verify this simply by expanding and collecting. Remember that if you have a binomial, 2 terms, times a trinomial, 3 terms, you end up with 6 terms. 2 terms times 3 terms equals 6 terms. Works out well, just like multiplication. Okay, so say we have a question like x to the power of 3 minus 8. This would be pretty difficult to factor just by looking at it, but using difference of cubes, it's very helpful. So if we look at the pattern, we have something cubed, so our a is equal to x, and for the final term, we have an 8, so a is b cubed. How can you write 8 as something cubed? Well, 8 is 2 to the power of 3. So that means that b is equal to 2, because 2 to the power of 3 is equal to 8. So now we can fill in the pattern. A minus b, so x minus 2, a squared, x squared, plus a times b, 2x, plus b squared, plus 4. And we're done. That's it, that's all. So sum of cubes is also a pattern. I don't really have to memorize both because if you think about it, a cubed plus b cubed, it's really very similar to the difference of cubes, only if I want it to work out the same, I'd have to have a double negative. Because we have a power of 3, this would come out to negative b cubed, so negative and negative would be a positive. And then if we write it in this way, we can just use the formula that we had for difference of cubes. A minus negative b, a squared, plus a minus b, plus negative b squared. Little cramp there, sorry about that. Okay, we simplify a little bit. A plus b so this is the equation for the sum of cubes. So if you memorize one, you can just get the second one for free by subbing it in with a negative. Memorization's not my best skill, so I try to use shortcuts, and I try to figure out a way to like generate an answer or derive a formula instead of memorizing a formula. Okay, so we're gonna use this and we're gonna do another question. So factor x to the 3 minus y to the 6. A couple different ways you could do this. If you want to use the pattern here, then you have to think of y to the 6 somehow being something to the 3. So we'd have to rewrite it as something to the 3. So what could we write for the exponent so we'd get a 6? It would have to be a 2. So y squared to the power of 3. Oh, I wanted to make a sum. So now it's a sum. X cubed, oops, the a value would just be x, plus the b value would be y squared, So a squared comes next, so that's x squared minus a, and the b value is y squared plus b squared. So y squared squared is y to the 4. That may not be the only way to factor this question, but that's a way to factor it. It looks tempting with all these exponents, like maybe I could take out a common factor. No, maybe I could do something else. You know what? I think the sum of cubes might be the only way to factor this one after all. And that's how you use the difference of cubes and sum of cube formulas to help you factor.